Good morning, students. Today we are going to solve one physics A level question. This is in 2023 paper. You can analyze that A level. Okay, paper 4. Let us solve this one. Look at this. Part of an electric circuit is shown in the figure. Here, the missing component, they have missed some component. Okay, we will analyze the circuit. For what purpose it is used. Let us analyze that one and we will answer the questions. First of all, look at this. The circuit is used to produce half wave rectification of an alternating voltage. So clearly it is giving an idea what is the purpose of that circuit. So here the circuit is going to convert that half, that is convert alternating voltage to direct voltage through half wave rectifier. So it will allow only the half wave, that is positive half wave only will be allowed through the missing component. Let us analyze. I will reveal about that missing component after analyzing, that is after uh, giving the clarity in the concept of alternating voltage to the direct voltage. And then look at this here. Alternating voltage. Alternating voltage is having, this is the representation of wave function of alternating voltage, which is having voltage in the y-axis, time in x-axis. There will be a positive voltage, there will be a negative voltage difference through the alternating voltage input. But here, after passing the alternating voltage through the missing component, we are getting rectified voltage, that is called direct voltage. So the direct voltage will have only the positive potential difference. The negative potential difference will not be allowed by that component. That will be possible only with the diode. So the missing component should be the diode. So the diode will not allow the negative half cycle. How it will not allow the negative half cycle? It will act like a reverse bias. For positive half cycle, it will act like a forward bias. The positive half cycle only will be allowed. Look at this. This is positive half cycle. And then another one will be the negative half cycle. Wait a moment. Yeah, this is the negative half cycle. The negative half cycle will not be allowed. Only the positive half cycle will be allowed. So positive half cycle will be allowed by the diode. And then here, look at this. We are getting the direct voltage here as an output. But after getting that pulsating direct voltage, this is called a pulsating direct voltage. Pulsating direct voltage. So look at this. This is actually the pulsating signal. We are getting maximum value and zero. Maximum value and zero. Maximum value and zero. That is called pulsating direct voltage. That will not be useful for our usage. That's why we are going to pass that pulsating direct voltage through the capacitor. The capacitor will give smooth voltage. Smooth voltage will be from, that is the pulse will be reduced. Here it will not go to the maximum 5 and maximum 5 or 10 something and minimum 0. It will have some smooth curve. So smoothing will be there in the capacitor. The purpose of the capacitor is getting smoothing voltage from the pulsating direct voltage. So finally we are getting output. So I have explained about that diagram. After that we are going to solve that question. Let us solve this one. A component, yeah, already a component, missing component, already I have given diode, and I have represented that symbol also. And then state the effect on V output on including the capacitor in the circuit. So if they are not asking, are connecting the capacitor, you will get only the pulsating positive half cycle. But after that you will get the smooth recurve, right? So smoothing is the purpose of that circuit. Smoothing will be there through the capacitor. So you can draw the diagram here, students. Actually the diagrams will speak more things. Here look at this. So this is actually through the rectification. This is actually alternating voltage. When you are passing that through the diode, then it will allow only the positive half cycle. And then after through the capacitor, it will be converted into smooth voltage. So you can draw the diagram like this. Then it will give a clear picture about your understanding. And look at this. You may get confused here, ma'am. You have given the waveform, but they have given the square form. Actually, no, not an issue here. I have represented alternative voltage in the waveform. So here the pulse is not at all reduced suddenly, drop out. There is no voltage drop out suddenly. What I have represented there. Look at this. I have represented one wave function that is called sine wave function of an alternating voltage. But they have shown the square voltage, square form of that wave function. So square form means here suddenly at a particular time suddenly there will be a drop. Here look at this, at a particular time suddenly there will be a drop. But here there will be a drop smoothly. But here there will be a sudden drop. Yeah, alternate voltage can be there in any form, square waveform or sine waveform, any form it will be. But actually I have represented in the sine waveform. Why I have represented the sine waveform? Because in your book there will be an explanation with the sine waveform only, but they are asking the question with the square waveform, so you may get confused. In the book there will be a sine waveform, but in the explanation you have given the square waveform, means it will be, you may get confused for which one we can apply that concept. Like that you may get confused, you can apply the concept for both the one. That's why I have represented that examples with the sine waveform, but really they have given the square waveform. So look at this square waveform, square function, square representation of alternating voltage they have given input. And look at this. Here we are getting smooth curve. Look at this. Here, if only if you have applied that rectification purpose alone, what you will get actually, the output will be like this. The output will be like this. This. Look at this. The output will be like this. If you don't have the capacitor, you will have that pulsating waveform. But here we are having a smooth waveform, right? This is the representation. It's clear. It's a great one, right? After the capacitor, we are getting that one, right? Look at this. How they have plotted that graph. Okay, here there is a minimum value and the maximum value, right? Look at this. This will be useful for us because I think they are asking the question based, they are going to ask question, what will be the minimum value, what will be the maximum value, like that they can ask. So here there is a variation between the minimum and maximum between 0.02 to 0.04 seconds. Okay, let us check that one. Determine the frequency of voltage input. So frequency can be easily voltage input. What is the frequency? So frequency means we are having F is equal to 1 by T, right? So 1 by T is nothing but 1 by time period. Time period is nothing but the uh, time for the complete wave. From here to here, this is called a complete wave. So usually the complete wave will be like this. It will be started from one point and the same point will be reached after that, after crossing that negative part. So here look at this, it is having one point and then it will cross that negative point, negative potential difference, and then it will go to the positive potential difference again. So this is a complete wave representation, or wait a moment, actually this is not a complete wave representation, I made a mistake here. This is the complete wave representation, this one. It will start from here and it will end here. But anyway, whatever maybe, this is square wave function, that's why not an issue. Okay, look at this 0.02 to 0.06. So 1 by t will be what? So the complete time period for that one will be 0.02. 0.02 means it will be 0.04. 1 by 0.04. I think you can use the calculator, right? So 1 by 0.04. Why I'm asking you to check, use the calculator here, because I think you are the calculator is allowed for you, right? That's why you can use that one, or otherwise you can do like this also, 0.01 and then 0.025, right? So after that you will get 25, right? Okay, then so the V input, the frequency for that V input will be 25 hertz. Let me check whether they have given only in the time in seconds. Yes, because sometimes they will give in milliseconds. That that case you should convert that into seconds. Okay, because frequency unit is 1 by s, 1 by second. That is 1 by second is nothing but the hertz, right? 1 by second is nothing but hertz. the unit of the frequency. And then one more thing, here they are asking the time, show that the time constant for the discharge of the capacitor through the resistor is 0.038. So time constant is nothing but RC, resistance and capacitance. But actually we don't have a we are having resistance, but we don't have a capacitance, right? So we have to use some other formula. From the curve we can get that formula. So what is that formula? V maximum will be equal to V minimum in the variation, and then exponential to the power minus t divided by RC. Actually RC is a uh, time constant, right? So we are going to find out that RC, that is V minimum e to the power minus t by RC. In the graph, you can analyze one thing. V maximum will be, sorry, actually here, V maximum will be here, V minimum will be here. Yeah, this is actually through the capacitor. It is given in your formula itself. That is in the formula sheet they have given before starting that exam. You can analyze that one. So V, this one will be V minimum, and this one will be V maximum. So V minimum here will be, look at this, each and every point is 0.25. So 0.25 means this is 2.5. Actually, this is what is it? This is 2.5. This is 3, and this is 3.25. The minimum value will be 3.25, and then the maximum value will be 5 point. Let me check that one. What is that? Maximum value will be, everything will be 0.25, means every each and every that is this small division is represented as 0.25, right? So point 5.5, 5.5, and exponential to the power 0.02. So the voltage drop is there, that is the smoothing discharge variation, time variation will be 0.02. Look at this, the time variation between the maximum and minimum. This is the time variation between the maximum and minimum divided by tau. So when you are doing this one, you will get 0.038. I will show the working calculation part. You please refer this one. Thank you, students.